Guys, here we are going through one exam question showing how trigonometry can be used for modelling. Let's go. On the 18th of March 2019, there were 12 hours of daylight in Inverness. On the 16th of June 2019, 90 days later, there will be 18 hours of daylight in Inverness. Jude decides to model the number of hours of daylight in Inverness by the formula n is a and b sine t, where t is the number of days after the 18th of March 2019. Part A wants us to state the value Jude should use for a. Okay, so we know that when t is 0, n is 12, so a is 12. Okay, then we want to state the value Jude should use for b. So we now know that n is 12 and b sine t. Now we know that when t is 90, n is 18. So we get 18 is 12 and b sine 90. Sine 90 is 1, so we get just add b. Therefore, b is 6. Okay, then for part 3, using Jude's model, calculate the number of hours of daylight in Inverness on the 15th of May 2019, 58 days after the 18th of March 2019. So we're plonking in t is 58 into n is 12 and 6 sine t. So we get n is 12 and 6 sine 58. And the one decimal place we will get 17.1. Okay, then for part 4, we want to use Jude's model to find how many days in 2019 will have at least 17.4 hours of daylight. So we are solving then 12 and 6 sine t. Now we want that to be greater than or equal to 17.4. Now if we take 12, we get 5.4. Divide that by 6, we want sine t. Greater than or equal to 0.9. Okay, now then, if we inverse sine 0.9, then we roughly get to the nearest day, we get 64. So that means the 64th day after the 18th of March is the first day to have at least 17.4 hours of daylight. Now, there's also, so what's going to happen then, because we're dealing with sine, is the number of hours of daylight is going to increase up to the maximum, which we know is 18, and then it's going to decrease again. So now we need to find the first day, or the last day, that fits the inequality. So, if we sketch the graph, then we're interested in the part of the graph which is 0.9 or above. So we know this point was 64. So the one on the right is going to be 180 minus 64. Which is 116. So the 116th day is the last one to have at least 17.4 hours. So the total number of days is 116 minus 63, because the 64th had it, 63rd didn't. So 116 minus 63 gives us 53 days. Okay, then for part 5, we want to explain why Jude's model will become inaccurate in 2020 and future years. Okay, so the model works on sine of t. Sine has a period of 360, but there are 365 days in a year. So after 360 days, the model starts to repeat itself, so then it's going to fall out of sync with the years passing. Okay, then the final part, and this decides to use n is a and b sine 360 over 365 t. We want to explain why this is better than Jude's. So the reason it's better is it takes the number of days in the year into account, whereas Jude's did not.